I wanted to record a quick extra video showing the case where the side opposite the given angle is greater than the other given side. We've talked about this giving us one triangle, and I want to point out how we don't really need to recognize that right away, although it's pretty clear. The side opposite the given angle is greater than the other given side, and we know that that should lead to one triangle. Let's see how it works in the numbers. So this is the ambiguous case of the law of sines because I have a side opposite a given angle, but another side rather than another angle. We set things up the same way. We take the sine of 36.87 and divide that by the 12. And this should equal the sine of beta over 10. We solve for beta in the same way by taking the sine inverse of 10 sine of 37, sorry, 36.87. That's the height, the 10 sine 36.87, and divided by the 12. So we're finding the sine inverse of, let's find that fraction. So 10 sine 36.87 divided by 12 is 0.5. And we know that there are two angles with a sine of 0.5. We do a sine inverse. That gets us a 30-degree angle. That gets us a 30-degree angle. That's the angle in the first quadrant with a sine of 0.5. So we also have to find the other beta, which is 180 minus the 30 degrees. So 150. So now we have, these are our two triangles. One with a 36.87 and a 30-degree angle and the third angle, and the other one has a 36.87 and a 150. So right away, we should see that there's a problem with having this 150-degree angle because there's no room for a third angle. We're already over 180 degrees. So when we go to find our first gamma, we subtract from 180. So we do 180 minus the 36.87 minus the 30-degree angle. These are all degrees. So if I do 180 minus 36.87 minus 30, that leaves a 113.13. That's one of my gammas. When I go to find the other gamma, what's going to show, it's going to end up being negative. So here's our other gamma from our second triangle, which is not going to actually exist. We subtract the 36.87, and we're also subtracting 150. And that's going to end up being negative. So that'll be negative 6.87. Since that came out negative, that's when we should notice, hey, there's something wrong here. And then we go back to our original information and recognize that the side opposite the given angle was greater than the other given side, and that means we're only going to have one triangle. So we get to ignore this negative 6.87. And this is where we say, oh yeah, this is a one triangle case. And so I don't need this other beta. I don't need this negative 6.87. I've only got one triangle. The only beta that we get is the 30-degree angle. The only gamma that we need is the 113.13. We do still need to find C, and I'm still going to use the given information to find C. So I'm going to take the sine of 36.87 divided by the 12. And this should be equal to the sine of gamma, which is 113.13, divided by the side C. And so this tells us that C will be 12 times the sine of 113.13 divided by the sine of 36.87. Note that in this case, we do not need a sine inverse because we're looking for a side and not an angle. So 12 times the sine of 113.13 divided by the sine of 36.87 gives us a side C of 18.4. So in summary, we know we can get, in the side-side angle case, it's ambiguous because we could get 0, 1, 2, or 1 triangles. We get 0 if the side opposite the given angle is too short, that is, it's less than the height. If the side opposite the given angle is equal to the height, then we get 1 right triangle. That one's hard to land on. If the side opposite the given angle is greater than the height but less than the other given side, that's the 2 triangles case. After you find the first angle, the angle opposite the other given side with the law of sines, you subtract it from 180 to find the potential second triangle. Now that we've got 2 angles, alpha and beta, well, an alpha and 2 different versions of beta, we take the alpha and the first beta that we find, and we subtract from 180 to get the third angle. Then we do the same thing with the second beta, alpha and this beta, subtract those from 180 to get the second gamma, but if it comes out negative, that's the 1 triangle case. We could avoid this subtraction if we noticed at the beginning the side opposite the given angle is greater than the other given side, and that's a 1 triangle case. That's all I wanted to talk about for this particular problem. I just wanted to, we ran out of time in our previous recording, so I wanted to record this example and I'll put it up there. That's it for this week. Everybody have a good weekend and thanks for playing.